Today, Anthropic's foundation models like Opus, Sonnet, Haiku, and tools like Claude Code, they stand as a top choice for builders, and rightly so. You've probably heard words like tokens, context window, agents, subagents, MCP, system prompts thrown around. Maybe you've made some sense of them individually, but to actually get them to work, you need the full picture. You need to break it down to its components, understand what each one does, and then build up to see how the entire ecosystem fits together. That's exactly what we will do today. Our focus in this video is to understand Claude AI ecosystem and tooling around it. I have built a diagram to make it easy. We'll go through the terminologies and vocabulary you keep hearing surrounding the AI tools. What do they mean? What do they do? As you can see, all the components are color-coded, and their legends are also defined here for easy understanding and correspondence. We begin with the focus on Claude by Anthropic, and then the foundation models like Opus, Sonnet, and Haiku, how they differ, what makes them good or let's say suitable for a particular task, like complex tasks or regular tasks, when to use what are the trade-offs in token usage. So let's begin with the word token. What is token exactly? So think of token as the smallest unit of text an LLM can read or produce. A token is roughly like 3/4 of a word in English. Take an example word engineering, which is one token, and then another word unbreakable, which is either two or either three tokens, depending on the model that's used for tokenization, let's say. The LLM does not see the characters or words. It sees the sequence of token IDs because each token is mapped to a particular number. So it's a fixed vocabulary in the end. Every input you send or receive from LLM, it is actually a tokenized sequence. So now we talk about the agentic AI experiences in Claude ecosystem. But first of all, what's an agent? So an agent is simply a goal-directed process that operates within a particular context window using an LLM and tool calls like MCP, which we'll talk about a bit later. We will also define what is context window, but now let's take it as a memory of an agent. So that's all about an agent right now, yeah, at this stage. But how many forms do we get with this agentic AI experience? So the very first form we can take a look at is the web agent. That's available directly on the Claude website, right? You use Claude AI and Claude.ai, and that's where you get started. Most of the time, we use the web interface for chat, but then for the proper agentic experience, you get a Chrome plugin built by Anthropic. Let's take a look at that. So if you use Chrome or Brave browser for that matter, and you go to the Chrome extensions store, you can simply look for Claude built by Anthropic and add it as a Chrome extension, which I already have added. Once you do, you will get this button here to enable this plugin. It will ask you for authentication. I've already authenticated it. And once you authenticate, it will give you this interface where you can choose the models and you can give a task to complete to operate within the context of a browser window. The second option to use the agentic AI experience within Claude ecosystem is the desktop agent. How does that look like? So this is the native desktop app. I shouldn't say it's native. It's packaged as a native app, but I think it's running in Electron or some sort of JavaScript runtime. But anyways, that's the desktop experience you get. In here is the chat experience where you can choose the models and extended thinking and the previous models. But then you also get the cowork. which is actually the computer use agentic experience. So you can ask it to do tasks like organize your files and use certain automation in computers, right? So you can build such agentic loops in here. And then you get Claude Code kind of experience within the desktop. So here you can show the path that could be local, that could be remote, like GitHub or so. And you can choose a local Git tree and you can begin working on it. Very recently, Claude added Git work tree, which we will talk about a bit later, of course, because it's not relevant to what we do right now. And then with prompting, you can begin a proper agentic experience, like it will help you write code, plan, whatever you like. What's next? So the third mode is the actual famous one, which is the command line interface, terminal interface, Claude Code. Let's take a look at that. So here in the terminal, if you simply say Claude, it will ask you for the necessary permission. Once you allow that, that's where you get the Claude Code CLI. And in the CLI, you get everything. You get all sort of slash commands, configs. You get all sort of login, logout, meaning you'll be able to use your account with Anthropic. You can create your skills and use in here. You can create your own slash commands and use in here. We will talk about all of this a bit later, not now. Right now, we understand the ecosystem. The fourth one, which I use a lot these days, is via ACP protocol. Now, ACP protocol is the agent client protocol, very simply. And what does it mean? It means that you can use an ACP compliant editor or IDE and get the whole Claude ecosystem experience within the IDE. So very quickly, let's take an example of Z, because Z was among the, or perhaps the pioneer of ACP protocol that was later picked up by JetBrains and others are now picking up. So in Z, this is what you get. Within the AI panel, if you choose a new thread, you can choose an external agent, Claude agent. And this is the ACP. This will authenticate with your Claude Code. If it is not authenticated, it will ask you to do so. And then you can use the entire Claude Code, all the skills, configs, slash commands, everything from this prompt. And now, what's the context window? So remember we said context window is the memory of an agent. So more precisely, context window is actually what an agent has to operate within, right? So for example, if you fork an agent or you create a sub-agent, it will carry its own context window. So you can even say that an agent is actually a context window during an operation or agentic AI operation, right? Now, that's mostly for understanding, right? So what is a context window? It's actually the maximum number of tokens the LLM can hold or handle within a working memory of an interaction with agent, right? It includes the input and output, both. And remember what's a token? A token corresponds to words in a language. Engineering is one token. Unbreakable is either 2 or 3 token, depending on the model. So depending on the input, the tool call, the system prompt, user prompt, and the output from the LLM, all of it adds towards the context window size, which is built on the tokens, right? And being able to handle a lot of tokens gracefully or a limited window size of token, but very well, that defines the quality of experience that you get from an LLM. By the way, these days, Claude is experimenting with a 1 million tokens context window. It's available in beta through the APIs, not through the Claude Code subscription like Pro or Max subscriptions. But I guess pretty soon it will be available, right? You see the brown colored boxes here? They are relevant to Claude Code. They include the config files. We talked about context window, We are now going to talk about system and user prompts. Then we'll take a look at settings and skills, etc. All of them operate together to build an agentic AI experience for you. So if you configure them well, you will have a good experience or a customized experience, let's say. But out of the box, you will get still quite a good experience with Claude Code. But anyways, what's a prompt? So let's first talk about system prompt. System prompt is the instructions given to LLM, which are set as config. For example, Claude.md. Claude.md will go to the LLM along with your prompt every single time. So any changes you make to Claude.md must be more about the styling, your preferences, the do's and the don'ts, and it should be precise. It shouldn't be way too long, otherwise it will eat up from the context window quota, of course. Right now, this is the system prompt. Along with Claude.md, there is a memory.md, which keeps changing every once in a while you're working with the LLM, but that's for a bit later. For now, let's focus on Claude.md as it is a fixed system prompt. And memory MD is limited to 200 lines of markdown file within the system prompt. Along with that, we must understand what is user prompt. I guess you already know user prompt is the instructions or the chat that you write to the chat text area to the LLM when you're interacting with the LLM. So what's the difference? Let's take a look. So here, that's Claude Code CLI. If I write as a user prompt, explain to me gravitational lensing like I'm a high school freshman. Now this is my user prompt. Besides this user prompt, I wouldn't give any other instructions to Claude, how to behave, how to explain the preference of persona or the kind of vocabulary that I prefer, etc., etc. But I can configure all of it in my Claude.md file, which I have shared in a GitHub repo, by the way. I will copy the link in description. But very briefly, it's a markdown format, and it's precisely how you want Claude to behave every single time. So I have a certain preference with the response style. With the style when Claude teaches me, I have certain engineering principles, a way to do task management. I do build software a lot, so I have particular preferences for code style, then a preference for SQL, then context management, which I will elaborate in a while, and then documentation. So what's my preference when the document contains diagrams? I prefer mermaid diagrams, and when it's math, I prefer LaTeX. So that's all about the system prompt and user prompt. So remember two parts. One part, your config, like Claude.md, which will explain how the LLM should follow the guidelines, or let's say the guardrails, when it is giving you the response or building up something for you. And then the user prompt, which is actually your part of the picture, where you have to have good communication skills to define good prompt. Remember, if you don't define a good user prompt, the result, the outcome, might not be what you would be expecting from even a good quality LLM. So I'm not saying to be writing into like XML or JSON or something like that, but be as precise, as clear, and as organized in your prompt as you can. Like by organization, I mean like keep a markdown format if you can, or otherwise at least keep 3 backticks if you want to delimit your message. For example, something like this, right? So let's say if I ask Claude to explain to me gravitational lensing, like I'm a high school freshman, and I would want to say that, okay, I got something from a website about physics, and this is what it is. So following, let's say, a physics textbook. Now in here, you can write in three backticks that gravitational lensing is whatever, blah, 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 end it with three backticks. So now Claude will know how to delimit the text that you received from the textbook very clearly, and what are you looking for? What's the goal that you're expecting? And the guardrails will follow from Claude MD. I hope that makes sense. Let's talk about ACP very quickly because it's just beside MCP, which we are going to talk about. So ACP, remember, is the Agent Client Protocol. MCP that we are going to talk about is also a protocol, but these are very different things, right? So Agent Client Protocol allows you to use Claude Agentic AI through the ACP compliant editor like Z or IntelliJ or VS Code. And MCP is, however, a different protocol, right? So we have already covered ACP, so I wouldn't go into elaborate details there. Let's talk about MCP. So MCP is Model Context Protocol. MCP is actually the oracle for an LLM. By oracle, I mean like if an LLM wants to ask something from the internet, let's say, or from the archive of books, or from a REST API, or an LLM wants to use a terminal command to get the directory listing, execute something like a shell command and get the output, it executes everything through MCP. So MCP is quite interesting. It was actually developed by Anthropic, and later on it was standardized, right? So industry adopted it very quickly because in the AI landscape, as you know, things are moving very fast, and wherever we see progress, everyone gets, tries to get their fair share, which is quite natural. So anyways, LLMs could enable the use case, for example, when you want to know the current weather of any geographical location, you would ask. When you want to connect with your agile board like Jira or your knowledge base like Confluence, all you need to do is connect Claude Code through an MCP protocol, so MCP endpoint, and then you can ask Claude to do those queries into your MCP connected resource, right? So you can read about MCP on Anthropic's website or over the internet. It's very easy. You can ask LLM to explain that to you, but very simply, MCP is actually the interface of tool calls to any resource that's available to an LLM. So very simply, what happens is that when you prompt, so when you provide your user prompt, and the LLM figures out that this user prompt may be better served by calling particular tools that our interface of our Claude Code is connected with, the tools listing, through tools registries, gets to know it. So the LLM will direct the client to make these tool calls. So the client is MCP client, which will make the tool call to MCP server. And then the result of the tool call will be given back to LLM. And then the LLM will include that in its context and give you an output, or maybe choose to make another tool call to the same system or another system. So that's the entire agentic loop or agentic iteration that we're talking about. I hope that's making a lot of sense. By the way, in a later video, we will deploy our own MCP server locally, and I will also show you how to connect with a remote MCP server. We will also see, once you deploy it, how do you connect with Claude Code and how do you even use it. So before we end this call, I will let you take a look at the holistic picture. Let me turn off my camera. Yeah. So this is the entire picture that we just talked about in detail, every single thing. So we broke it down into components. We understood from the first principles very simply, and then we built up the entire picture, and here's that full picture. And now I will show you how exactly an MCP call works. So let's take a look. So let's say you are the user and you want to check how the weather is right now in Dubai, let's say. So you have weather API, you will make your API key, and then traditionally, since it's an HTTP API, you will make an HTTP request through your terminal or HTTP client. Let's just say URL request, very simply. So you will define, you will request it with whatever verb and noun the weather API defines, like curl-iv https weatherapi.com/version/weather query city equals Dubai or something like that. That's the format of your request, the information that has to go in your input. So the API could return back the weather to you right now, or whatever data it has for that matter. And you can see this is a fixed format. This is not a flexible, like prompt style thing. On the contrary, let's say if you have MCP server for weather API available to you, and you are connected, or you have connected your Claude Code to that MCP server, which in turn eventually connects with weather API, how would that experience look like? So as a user, you will provide a user prompt to Claude Code. How's the weather in Dubai? Now Claude Code knows that it has to send it over the user prompt and the system prompt. Remember Claude.md and other configs. So Claude Code remembers that it has to send it over within this context window to Claude LLM, let's say Opus in our case. And then the LLM doesn't know the weather right now in Dubai, right? It's not part of its training, and it's not a live system as such. Its understanding and knowledge depends on its training cutoff date. Today, if you use LLM, let's say Opus 4.6, its knowledge cutoff date will be likely somewhere in May 2025 or so, yeah. And it needs to make an Oracle call to some resource or some system that could provide the weather data to it. So LLM would know through Claude Code's context and the tools registry that there is a weather API tool call or weather API MCP connectivity available to it. So LLM would likely respond back to Claude Code, make such and such tool call to weather MCP server. Claude Code then will make this tool call via JSON RPC to weather MCP server, and then weather MCP server internally will make an HTTP client call just like this box to weather API, return back, which will return back this data or error depending on the request, whatever. And then whatever the response is, it will translate that back to Claude Code. And at that point, Claude Code will return it back to LLM. And the LLM will now decide, should it end and return back the response to user by drafting the output using the guidance and the guardrails within the system and the user prompt? Or should it make any other tool call or do something else? So let's say in this example, the LLM decides that, okay, I have the weather data and that's what the user requires. And in the config file, it just doesn't say anything about how to treat weather in particular. So let's give it back to the user. So it will furnish the response, give it back to Cloud Code. And that's what Cloud Code will return back to the user, that it's such and such degree Celsius. Is it a rainy day or a sunny day? Good for picnic or not, etc. And yeah, let's take a quick look at the skill files. Although we will talk about a bit more detail on how to create your own skills or how can you modify, customize, and make it according to your preferences and style. For now, I have published my Claude MD, my skill files, my slash commands in GitHub repo. That's open and MIT licensed. I will share the link in the description. It will contain a README file, which will give you very simple to follow steps, which will tell you how to copy, where to copy the files. in your Claude Code setup, and then you can use those skill files and Claude and the config file yourself. But let's take a quick look. What exactly is a skill file? How does it look like? So under your .claude directory, you will have a skills subdirectory, right? And then you can see that I have defined quite a lot of skills for various purposes. You can create your own skills as well, like I said. The pattern is quite simple. You have to create a subdirectory, let's say for Rust, right? So Rust dash skill is the name of the subdirectory that I put. Under that subdirectory, I have to have a skill.md file. The skill.md file has to be in a proper markdown format. It has to begin with the name and the description, at least. So the name of the skill, let's say, is Rust. And the description is like always load for .rs, Rust code, cargo projects, Tokyo, and so on. I've defined my versioning policy, core philosophy and design principles, the way I want to design the modules, what I think about performance, how to tell when to break the rules, and properly document them. And you have to, you can take a look at the entire skill file because I put it in GitHub repo, whose link is in the description, like I said, and see if you want to use it, you want to modify it for your own use. This way you can define any other skill. So, for example, Python skill file, right? So Python is skill. So I try to keep all the skill files in a similar pattern, which helps me organize them and modify them as I evolve my own usage and as I experience my own growth. So I would recommend the same to you. And I guess that's all for now. I hope you had a brilliant experience. Take care.